Rolling.
Hi, I'm Marm Seiko. I'm an ILS PhD student. I work in Brian Pirelli's lab. Today we're looking at, so what my focus is biological and evolutionary, basically looking at biological and evolutionary markers as a way to look at schizophrenia as a whole. So schizophrenia, just to give a quick rundown, so the most overused example on the planet is Dr. Nash. He was a paranoid schizophrenic. It looks at a beautiful mind and how he perceived the world as a schizophrenic versus someone who does not have it. Schizophrenia is chronic and severe. These are the symptoms: hallucination, delusion, etc. It's treatable, but we have compliance issues. Most symptoms do not appear until early adulthood. What causes it? So that's what we're here for. So what causes it? It's complicated, but what we know is that it runs in families, so there's a genetic component. And what we want to know is that genetic component attached to any chemical components. So what I want to do with the evolutionary approach is go on a non-codon based model. So in a codon based model, we look at coding and not coding, and we're just kind of like, that's important, that stuff that we don't know about isn't. Instead, I want to look at each site in this supposed locus, and I made this up by the way, and look at how conserved is each site. And looking at that, it's how conserved is each site, and looking at them relative to all the sites in the locus. And this is available population data that we're using with clinical and case control data. And then I want to look at the SNPs and the SNP variants, so insertions, deletions, and see, okay, relative to the other sites, the SNP that we know in this locus is the most important. Is it actually the most conserved? So this is preliminary data between two clinical SNPs. And what we saw is that that's the background, so the background level of conservation. Z transformed to normalize it to all the other SNPs within that window. And what we find is generally, as you go from vertebrate to primate, because we're newer, we tend to have low levels of conservation. And when we look at the SNP relative to that, sometimes we have that it's highly conserved in the past, not so much right now. And then sometimes we have that it was lowly conserved in the past and more highly conserved relative to this window right now. So what can we do with this? In the short term, we can look at it as, let's not just look at one SNP, let's look at the whole site. And let's see the variation within the site, and is this whole region highly conserved? Is this whole region important? We can divide it into population, and this is actually our future direction, divide it into different populations and look at whether specific populations have schizophrenia that is more common, less common, and can we come up with long-term, can we come up with treatments? Can we attach these variations to and these mutations to actual upregulation and downregulation of particular hormones? And can we expand and contract and not limit ourselves to being this one SNP that is associated with schizophrenia? Because unlike certain diseases and conditions, there isn't always one SNP. Sometimes it's multiple SNPs and multiple things going wrong at the same time. Yeah.
Is that the end?
Yeah.
Oh, sorry.
I'm sorry.
I thought you were telling him to advance.